Hello, everyone. This is the MRMIA broadcast. This is the Model Risk Managers International Association broadcast, and I am your host, Mark LaPrince. And as our first broadcast, we recognize that many of you are going to be first-time listeners. So one of the things that we're doing as part of our beginning series is to actually go and introduce each of the board members of the MRMIA group and have them cover a key MRM topic of interest. So today we have Peter Quell, and he has a PhD in mathematics and a diploma in mathematical finance from Oxford. And he is here to discuss with us why he joined MRMIA, as well as best practices for machine learning validation, as well as a paper that he's working on to um, store those best practices. So Peter, why don't you go ahead and introduce yourself?
So thank you very much, Mark, for this kind introduction. My name is Peter Quell. I'm heading the portfolio analytics team at DZ Bank in Frankfurt, Germany. And in this context, I'm responsible for market risk and credit risk. So I have a lot of experience concerning model development and model validation. And a few years ago, we discussed with David Bennett that validation activities and also model risk activities should have some sort of professional standardization. And since the industry was lacking organization to cover this, there was the idea to found the MRMIA Association. And now we are a little bit further in the development process, and we are setting up several work groups covering different topics. And today we are covering one topic I'm heading. It's the machine learning and model risk part. In this context, we try to discuss the emerging relevance of machine learning in the financial industry in the context of model risk. And as all know, the most basic topic or the most basic document for model risk at the moment is the SR 11.7, published by the Federal Reserve already almost 10 years ago. And the primary aspect of this paper will be how should model risk or model governance framework be enlarged, modified, extended to cover also the machine learning topics. And today we are going to introduce this a little bit more detailed, but I think as an introduction, this is now setting the scene, so I give back to Mark.
All right, very good. So I know that you are have been working with the MRMIA group for a while on these workshops, and the AI and machine learning space is new to modeling in general. It's even newer to model risk and model validators. So to kind of start, I like to frame the context of this a little bit here. And one of the best ways to do this is with the SR 11.7 definition of a model. So where does AI and machine learning fit into SR 11.7's definition of a model?
Mm-hmm. So that's a very good point. I mean, of course, machine learning and AI has been around before 2011 when this text was written. And so I guess the regulator did not spend too much effort in trying to integrate each and every aspect of this growing machine learning topic into SR 11.7. Mm-hmm. But when you look at the definition of a model, which is roughly speaking transferring input to output via statistical or mathematical techniques, then of course also you cannot argue that machine learning is not a model, of course. So there is input, there is output, and there's something in between, but we can dive a little bit deeper into this, what is in between. So I guess via this SR 11.7 definition, machine learning is subject to model risk assessment via SR 11.7. But
Hmm.
When you read further the SI 11.7 document, you see that a lot of things need to be reinterpreted. Maybe they can be the
Hmm.
text could be as it is, but some you need interpretation. It's a little bit more interpretation. But in other aspects, you need a complete revision because
Right.
machine learning describes a completely different topic, and maybe it's not just a addendum to statistics. It's a little bit different, but we can come to this.
Yeah. So then that kind of moves into the next natural question, which is if SR 11.7's definition is not the most appropriate for defining an AI machine learning model, how do you define it?
So, roughly speaking, of course,
Mhm.
machine learning is, I would say, programming by data. You do not tell
Right.
the computer each and every tiny step it needs to do before solving a problem, but you tell the computer or the algorithm a little bit the target or the goal it has to achieve, and then you let the computer find the way to solve the problem. But this
Hmm.
is a very rough explanation. Of course, there's this classical definition by, I guess, Tom Mitchell, what
Yeah.
machine learning is. Maybe I recall it. You need to, so to say, gain performance by evaluating more data. And if you increase the performance by more data, then it's somehow learning. You may ask, what is the difference to statistics? Because also there, you may want to increase your amount of robustness or reliability, so to say, by collecting more data. But I don't want to go into these subtle details. Um, just for starters, I would say machine learning is programming by data.
Right.
The more data you have, so the saying goes, the better should be your performance of the algorithm.
That's right. That's right. So, um, and this is where we get into kind of more interesting topics around um, now that you've defined the model, and now that you know um, what the difference is between the traditional statistical methods you've been using versus an AI or machine learning one. Um, what is kind of the process for um, the second line to push or challenge the first line for reasons why they're choosing an AI or machine learning model? In the space that I work in, we're seeing a lot of talk and chatter about using AI machine learning for credit scoring, for things such as anti-money laundering.
Mhm.
But we're starting to see it creep into other spaces as well, such as even loan origination, uh, um, and credit risk as well. So um, I guess the question here is, um, how do you justify the use of an AI machine learning model? And is it important to make the distinction of why you chose that one as opposed to a traditional method?
I guess since we are at the beginning or near to the beginning of this machine learning revolution, so to say,
Hmm.
of course, there may be people who say that this already is stuff that is 30 or 40 years old, but let's just assume that we have seen the start of machine learning models within the financial industry. Then I would not make a very big separation between the classical methods and the machine learning
Okay.
methods,
Hmm.
because you have a target and you try to use models that are useful to reach your target. And if, for example, you think about money laundering or credit approval process and credit rating, credit scoring, then maybe you have a situation with a lot of input variables and you try to make sense of relationship between these variables.
Hmm.
And that has been done maybe in a statistical kind of way before. But now you see that finding some sort of relationship in a standardized way could be one benefit of these machine learning techniques. I mean, you have to distinguish, of course, between supervised, unsupervised learning, and
Right.
stuff like that. But in the end, I mean, people have to justify why they are using these new methods. It's not enough to say that they are now the best or they are hip or whatsoever, but you need to compare them with the classical models.
Yeah.
And this may then also be the first step towards a very important property of machine learning models applied in the finance industry. It's the topic of explainability. Once you have some
Right.
sort of easier model, some sort of surrogate model, or how you call this, then you may gain some confidence in using machine learning models. And if you compare these new machine learning models with the traditional statistical models, you may have the first case of such a surrogate model. And if it's always about performance, if the performance of the new model seems to be better and you can explain why it's better, then I see no big obstacle why we shouldn't use the machine learning approach. Maybe in parallel in the first phase, but in the end, maybe that is really the superior model. Depends on the case, but
right. So, yeah, and this is something that I've been running across many folks, is that the same rules apply for model selection. Just because AI machine learning is in the mix doesn't necessarily change the rules. We're still looking at performance. We're still looking at explainability and model robustness and all those other things. So that's very good to hear that the rules don't change for this piece. And so one of the things that you mentioned while talking about model selection is that the reason why AI machine learning models are being picked for certain use cases and starting out there is the volume of data and the variety of data and velocity of data. I like to kind of use those 3 V's there. So and because of that data dependency that these models have, much more so than other kinds, what is the governance framework that we should keep in mind when looking at the data input for these models, for validation, for production use, things like data drift?
So as you mentioned, the role of data seems to be much more important in the context of machine learning than in the traditional, I would say, traditional or statistical models. Some people say that machine learning is somehow theory-free because we let the data speak for itself.
Right.
This also underlines the relevance of data validation, so to say. And of course, and this is also seen in the context, where people are discussing ethical bias or reputation risk within machine learning algorithms. The training data set you present to the algorithm is determining what will be the result of the machine learning algorithm. I mean, if in the data you discriminate against a certain set of individuals, there is no wonder if the machine learning algorithm is doing the same kind of thing.
Right.
There has been court proceedings in this context, and I think a lot of companies have paid some sort of reputational risk, profit and loss for that reason. Be it in the context of job applicants or be in the context of credit approval or whatsoever. And this underlines the need for a good data validation step. I think there is not yet a best practice. There has not been best practice emerging in the context of machine learning validation. And one aspect of this white paper we are trying to work out within the framework of MRMIA is collecting some sort of emerging best practice, such that not every entity must invent the wheel for itself, but can draw on the experience of others. some aspects are quite clear. I mean, if you have these ethical risks and you know they are present, so you need to look if the data is balanced or if your machine learning algorithm is favoring one side to the other on some unfounded reason. So that is maybe the first step. But as I said, the emerging best practice is yet to be unfolded.
To be defined. So that and this topic of getting into validation is very interesting because there's been a lot of different approaches. No, just as you said, this is emerging. Nobody has really figured out kind of the best way to approach this. One of the ones that I've heard recently from Wells Fargo MRMIA is to test models until they break. Does that make sense in the context of machine learning models? Is it still important to know and identify when and where models break and the impacts of what can happen if it breaks?
I guess this is the same with the statistical models. I mean, I'm together with a colleague of mine. I've also written a book on risk model validation, and the question was, what is validation? And we defined it as the collection of all activities trying to break the model or trying to invalidate it. And once you're successful in invalidating a model, then you need to, or you know where to look for improvement. And I guess this approach of trying to break the model is very, very good approach. And since machine learning models are so heavily dependent on data, maybe that is the first place to look for. And as I said, the ethical or reputational risk aspect is one type of risk model breaking. I mean, you will not see the breaking in very curious results. You see the breaking in maybe somebody suing you in court because your model broke and you didn't realize it. But also on a technical level, you have to see that a lot of data is available, of course, but you need to understand what your model is doing and how it comes to the conclusion. And if you know that, then maybe there's a good way or good starting point trying to do the next step to do some sort of stress level in order to break the model. Or breaking a machine learning model doesn't mean that it's so to say running out of memory or whatsoever. It's just it starts to produce nonsensical results, and you mentioned that before. Anytime the environment, the data environment changes, of course, the machine learning model may be running out of representative training data, and then it will break. But this is the subtle distinction between the moment where it's working almost okay and the moment where it's almost working not okay. And you have to realize the difference between those two sides of the mirror, so to say.
Yes. So this comes up with the next natural question of how do you make that distinction of when the model is performing properly? In our space, we see a lot of folks trying to be more proactive with model monitoring, doing a lot more defining thresholds, running performance monitoring on a more regular basis, at the data level, at the model performance level, doing back testing. I've heard benchmarking come up a couple times, and there's also the concept of overfitting. So how do you ensure that this AI and machine learning model is staying on track and performing like it should?
So the very nature of machine learning is to optimize. I would say if maybe I'm harming some machine learning practitioners' peace of mind at this point, but all machine learning models try to optimize some performance measure. And if you monitor this performance measure and it gets worse instead of getting better,
Right.
then maybe you know there is something wrong. So this would be the first place. But one much more important aspect is, at least in the finance industry, you use models in order to make testable predictions. And this is, of course, what you alluded to, the backtest process. And this is one of the gold standards, be it in the context of statistical models or in the context of more progressive machine learning models. You need to make testable predictions. And if the test or the backtest performance is worsening, try to find the reason for that malfunction of your model.
Right.
One aspect which we talked before, the surrogate models. I mean, you could also try to reverse the role of challenger and champion model. So at the moment, maybe the benchmark model is the statistical or the classical model. And the challenger model is the machine learning model. But maybe in the future, it will be the other way around. And since the statistical model is not so much depending on very, very subtle features of the data set it was trained on, maybe you could also spot the moment of the machine learning model breaking when comparing it to a classical statistical model.
Okay.
And of course, your fourth point is especially important in the context of market risk, model risk building. You mentioned before, like fraud detection and credit risk scoring. I guess these aspects are quite traditional, and we have a lot of experience with machine learning models in credit risk. But on the market risk side, you have this problem of overfitting on a new level, because in the market risk framework, noise, so to say, is everything. You have a lot of noisy data. Your signal to noise ratio is much higher. And for example, if you compute the value at risk, the VAR, this is all about finding out how large is the noise. So usually, if you, let's say, consider your classical historical simulation as some sort of statistical model, you assume a constant mean, maybe, and a constant, constant mean value of 0. And you try to find the deviation around this constant value of 0. And then everything you are using in your value at risk computation is, so to say, attached to the noise component. And if a machine learning is not capable of separating signal from noise in a quite efficient way, then you have a problem, at least in the application of machine learning for market risk.
Right.
And in this case, we have done some experiments with that. In this case, I guess the classical signal filtering topics, which have been around the 50s or 60s, are working much more faster and much more successful at the moment, at least, than the machine learning techniques. I mean, of course, there is something like short-term memory and sequential learning topics, but at least in my experience, the signal filtering approach is a little bit better. But having said that, maybe in the future, people are much more aware of this overfitting topic for noisy data, and we see some improvements. I guess this will be the case, but I don't know when. And this is also one point we will address in this white paper, which we talked about, trying to see the different levels of applicability of machine learning. It's not the machine learning in finance. There's not one single topic of application, but you have different parts of the bank trying, for example, in risk modeling, trying to use machine learning. And especially in market risk, I see a lot of work to be done in the future.
That's fantastic. That's fantastic. And this, you know, I know we didn't talk about this earlier, but this almost, to me, begs the question of model deployment. And when you, are there any differences or considerations we should take in when deploying an AI machine learning model? One of the things that you mentioned like it's so dependent on the data. You have this data signal filtering aspect that kind of runs before it enters the model. Can you talk a little bit more about how some ways deploying a AI machine learning model might differ from kind of a traditional?
Mhm. So I can, of course, only talk about this in theory because we haven't used machine learning
Okay.
in so to say, my
Yeah.
framework. Because since I'm working in regulatory risk modeling, you know, regulators are a little bit cautious in adapting
Mhm.
machine learning techniques. So I guess at least in Europe, there has not been a single machine learning portfolio model
Wow.
at the moment. So I cannot talk about actual deployment, but once you start to deploy it, I think you have to have an intensive comparison with the classical models to see or to gain some sort of understanding how they are performing. And of course, you need to pay a lot of attention on explainability. I think
Mm.
in most talks on conferences about the application of machine learning in risk or regulatory risk, there's a big debate about what is explainability and how can we arrive at explainability. There
Right.
are two or three or more different lines of thought how to implement this explainability. And I guess moving forward, in order to set some best practice, we also need to focus on maybe the top two or three ways of showing to the regulator that this model is explainable. Because
Right.
if you have 100 ways to define explainability, that makes of course it makes sense in an academic way
Right.
to make a very comprehensive approach, but it's not practical. In, when we first try to implement these machine learning techniques, maybe you should focus on surrogate models or this technique called LIME, locally interpretable model
Yes.
agnostic explanations, or this SHAP, this Shapley value-based method where you try to compare different sensitivities. I
Hmm.
guess these are very good approaches for the beginning, but maybe there are new ways of explaining the results later on.
Right. That is a very critical piece, and it's something that needs to be, uh, addressed if AI and machine learning models are ever really going to be kind of adopted and deployed mainstream. I've been seeing this from just about every client I speak to, especially in the model risk management space. The big question is, can you explain the results, and
Mm-hmm.
why am I getting these ones as opposed to the others?
Mm-hmm.
And they'll do sensitivity tests to say, okay, I know based on these data inputs, it can translate to these outputs, and these ones can map to those, but it's not a true explanation. It's more a mapping of the the variety of answers you can potentially get.
Mm-hmm. Mm-hmm.
So, um, yeah, I'm curious to see how that evolves in the future as well.
Mm-hmm.
Um, all right, and then kind of last question, then I'll open it up to any remaining topics you'd like to discuss about your paper or the um, machine learning validation. Is the last question I have is the contingency plans around AI and machine learning models. We as model risk folks are in the business of managing models for when they break and when they fail, right? If they're performing, everything's fine. But what happens when an AI machine learning model fails? And what are some good backup plans
Mm-hmm.
or contingency plans a bank should have if, should they deploy one?
Mm-hmm. So I can only comment on applications in the context of risk modeling, of
Okay.
course. But you may also start one step earlier on what happens if one of your classical traditional statistical models fail. What
Right.
happens then? Do you have a backup for that? And especially in the context of market risk, I mean, you know this fundamental review of the trading book, where the
Hmm.
regulator says,
Yeah.
okay, you have an internal model approach, but as some sort of fallback, you also have to compute this kind of standardized approach. So there is
Hmm.
a fallback already implemented in the regulatory guideline, in the regulatory rules. And maybe you
Hmm.
can think about something like this also in the context of machine learning, applied to risk model context. Um, um, I guess in the risk model world, where you have people reading reports and then deciding about trades to make or trades to avoid, there is one human element in between, and there's not, like in algorithmic trading, this is a completely different topic, of course. Like in algorithmic trading, you do not have to you don't have separate uh, how to say a separate. You need a separate human entity to make the
Hmm.
decisions. But in algorithmic trading, you have an automatic execution of these trades, and that means
Right.
there's no form of human intervention anymore. And this might be dangerous because there's then no plan B. I mean,
Right.
maybe the P&L is then locked in, and you're done. In the context of risk modeling, you always have your limits, your people receiving the
Hmm.
reports, and I guess this is also some sort of backstop against some strange results. But
Hmm.
nevertheless, being prepared for the situation when the machine learning model is not providing any useful information is very good idea.
Okay. Yes. Very good. Very good. So before we kind of move on to our next topic and kind of introduce our organization, MRMIA, I wanted to ask you, was there anything else you'd like to cover about your paper, your upcoming paper,
Mhm.
and where
So
people can find it?
the main focus of this paper is, as we already talked about, the relationship between machine learning and model risk. And we like to start, as we did in the interview, with the SI 11.7
Hmm.
topic, and try to see where it needs to be enlarged
Right.
or modified. This is one line of thought in this white paper. But the second one is the topic: what is now new in this world where we
Hmm.
apply machine learning in a quantitative risk model framework? And there we start from the basics of machine learning to the different applications of machine learning within banking. This is, so to say, the starting point. And since at least in the last, let's say, 6 or 8 months, there's been a lot of publications concerning model risk in machine learning. The aim of this paper is not to invent the wheel once again, of course.
Right.
We're so trying to collect the available knowledge and try to select some emerging best practice, because
Hmm.
we want this white paper to be a useful document for model risk practitioners. Not, of course, also academics may see some interesting aspects, but in the first place, we want to have a good kind of documentation for model risk practitioners in order for them to judge what could be the benefit of these techniques. And once we decided to use the machine learning within our organization, what do we need to take care of once we come to the model risk governance or model risk management framework?
Right.
So we need to have a paper for the practitioner. Of
Hmm.
course, there are a lot of references to machine learning basics and all these fancy algorithms. But in the end, we want to have something that is tangible for so to say,
Right.
as a document can be, for the model risk management practitioners.
That's fantastic. Give them a solid framework they can use.
Mhm,
That
mhm,
will be immediately useful.
mhm.
That's
And of course,
yeah.
since this topic is evolving, also this white paper will be
Mhm.
evolving. I think if you look back in 3 years to 2020, you will see that this was a very preliminary approach in our first
Right.
draft of the white paper. Some aspects will be funny, other aspects will be quite interesting. So also this is evolving practice, but since a lot of people will apply machine learning in the future, we see a need for some standardization, because
Right.
otherwise you will discuss topics with your regulator again and again, or with your board of directors again and again. And this is maybe not the most efficient way to deal with your time.
Mm-hmm.
If there has been some sort of emerging best practice, name it,
Right.
and try to contribute to it.
That's right. And I'm just completely fascinated by the fact that this is universal, right? I'm over here in the United States, and you're working in Germany, and from U.S., Europe, UK, Asia is starting to develop model risk regulations as well. These are kind of universal standards that everyone can follow.
Yeah, that should be the goal. I mean, there will always be different regulatory interpretations, and there's also some sort of evolving standard. The German regulator has published a few papers on this. I guess the PRA in Great Britain also did that.
Right.
And the FED and the OCC contributed to these topics. And you see, of course, in the detail, you see differences.
Right.
And nevertheless, that was the same kind of state as with market or credit risk 20 years ago. So this is a natural observation.
Right.
But the topic is too important to be just left for its own development. You need to somehow bring best practice insights into the process, such that we can all benefit from each other's experiences.
Exactly. So let's change gears a little bit, and let's talk about MRMIA, the Model Risk Managers International Association. And so you're writing this paper as part of this effort, part of this group to establish these best practices. So in your own words, what is MRMIA?
So just with the acronym, it's the Model Risk Managers International Association, and it was founded a few years ago by Daniel Bennett. And the main reason was to get some sort of standardization in model risk management, some sort of standardization model risk validation, such that we do not, as I said, do not have to invent the wheel again and again, and to provide the practitioners with some sort of guidelines for this new evolving topic. It was then quite new, the model risk topic. It is now a few years later, it's now starting to settle. But the same topic is with the machine learning, which we discussed before. We have a new kind of topic in the industry concerning model risk or model validation, and we need to find some standards. And we are trying to build a platform such that people who are interested in forming these standards have their say and can tell us what their experience are and how we can improve the topic.
Excellent.
And since MRMIA is solely focused on model risk, we are also distinguishing ourselves, so to say, from other professional organizations, which have maybe a similar task in mind, but they apply it to market risk, credit risk, or operational risk, or other risk standards. And we focus on model risk, because in the beginning, when we founded the organization, there was a lot of also some sort of philosophical investigation. What is model risk?
Right.
And this philosophy is quite interesting. Maybe if you talk on the weekend about these things, but during work days, you need to have some tangible stuff.
Yes.
You need to be prepared to apply these concepts and not just talk about them in metaphysical terms.
Right.
And I think the industry has succeeded in this area. We have made it a little bit more tangible. There are some emerging best practices, but still we have a lot of education to do. And this is the second point, which beside the standardization aspect, was in Daniel Bennett's mind when founding this organization. He wanted to have some sort of educational set of topics.
Certifications
Or
and
certifications, yes.
yeah.
And some business or professional standard.
Yeah.
Where people could draw on when they are performing their task as model risk managers. Having some certificate and having some sort of educational material that every starter in the subject of risk model validation or risk model management can consult and can benefit from.
Right.
So these are the aspects: standardization, education, and certification.
That's excellent. That's excellent. So why did you choose Malrus, the MRMIA group?
So I was also one of the founding members, and Daniel then persuaded me to join this undertaking in an early stage. We got to know each other in the context of one journal on risk model validation, and we saw the need that we have to form an organization beyond just these papers in this journal. You need to have a little bit more informal platform to exchange ideas, and this now comes to some sort of benefit or some sort of realization in these efforts that yet you now see, which are accompanied by some white papers.
Right. Okay. And then last question here. Why should other professionals look to join the MRMIA group?
So the first aspect is that there's a lot of model risk debate going on at the moment, and everybody who is dealing with this will find some benefit, some help by consulting our best practice papers or white papers once they are out. So we want to establish MRMIA as a kind of platform where you look first when you want to know something about the best way to deal with model risk management in the banking industry at the moment. But as you said earlier, maybe we will get also some better insight into other industries as well.
Right.
And the second point is that this MRMIA organization will provide a platform for quite informal exchange of ideas. You don't need to write a complete paper when you only have to say a small paragraph, which is maybe of quite big relevance to others. You don't have to wait till you have enough material for complete paper, but you can try to be flexible in the interchange of ideas.
That's right. That's fantastic. That's a great vision. So that just about wraps it up. I just have one last fun question for you. What do you have a particular favorite topic of MRM, and what excites you the most about it right now?
Of course, the lengthy topic of machine learning in model risk is one of my favorites at the moment. And since I'm historically been involved in the trading book model risk activities, I try to extend the machine learning application also to market risk models.
Mm-hmm.
And when I started this a few years ago, I have seen that there is not too much stuff being published. I guess in algorithmic trading or some other areas at which our bank is not involved. There has been a tradition of using automated trade execution or automated design of trades for algorithmic trading. But in the context of market risk measurement, the case, and so I try to find out why nobody is or has been using machine learning in the context of market risk modeling, and what can be said about a way of how market risk models can benefit from developments within machine learning. I wouldn't say that it will be a success story. Maybe machine learning is only applicable to the big data environment in the context of credit risk, and not so much in the, let me call it, small data environment in market risk. But let's see if the community can prove me wrong, and we find some way of dealing with this also in the context of time series or sequential analysis.
Right.
That is my main passion at the moment, and this is also what I try to contribute to this working group and to the MRMIA platform.
Excellent. Yeah, you're a pioneer, man. You're setting the blazing the trail for the rest of us to follow. So let's see where it goes, and let's hope those machine learning models do produce some value. So with that said, to everyone and our first listeners of the MRMIA broadcast, thank you for joining us today, and we hope to see you again next time.
Okay.
Yeah.
Goodbye.
All right. Take care.